We have seen so far Dalton's atomic theory, Thomson atomic model. So in this class we will see Rutherford atomic model. Scientist Rutherford, he has given his own atomic model. Let us see what is Rutherford's atomic model. Now before that we will see Rutherford's experiment. Rutherford conducted an experiment. So he conducted Rutherford scattering experiment. The experiment is called Rutherford scattering experiment. Based on this experiment, he has given his postulate on the atom. Let us see here. See, Rutherford's experiment. This is the experiment. It consists of a radioactive source. This is a radioactive source, a device like. This is a circular screen. So alpha particles are emitted by this radioactive source. Alpha particles are positively charged particles. Alpha particles are emitted by this radioactive source. These alpha particles pass through and fall. These particles fall on gold foil. This is gold foil, metal gold foil. Thin gold foil. This is a gold foil. It is like this. It is very thin. The thickness is 100 nanometer. Very thin gold foil. Behind the gold foil, a circular screen is kept. This circular screen inside is coated with, here in this area, it is coated with zinc sulfide. The circular screen is coated here with zinc sulfide. Zinc sulfide. Zinc sulfide is the phosphorescent material. It will emit light when it is struck by the particles. So it is a phosphorescent material. So Rutherford fired alpha particles. So these alpha particles pass through the gold foil, and Rutherford observed that most of the alpha particles pass through the gold foil, penetrate through the gold foil, and these particles fall behind the gold foil. It falls on the screen which is coated with zinc sulfide. Most of the particles penetrate through the gold foil. Most of the alpha particles pass through the most of the alpha particles pass through the gold foil. Right. That means that the gold atom, the most of the places of the atom are vacant. That is, it is easily the particles easily pass through the gold foil. Some alpha particles are deflected at small angles. See here, this is one alpha particle which is deflected like this. Here is another alpha particle which is deflected. Therefore, some alpha particles are deflected at some small angles, and very few alpha particles are deflected back. That is almost at 180 degrees. It is deflected back at 180 degrees in this direction. Very few alpha particles are deflected back. So based on this, he has come to the conclusion, most of the alpha particles pass through the gold foil. That means most of the place of the atom most of the places of the atom are vacant. So therefore it is easily, the alpha particles easily pass through the gold foil. These particles fall on the screen. This screen begins to glow. As the alpha particles fall on the screen it begins to glow, because the screen is coated with phosphorescent zinc sulfide material. So he has concluded, the alpha particles which are deflected back, they are deflected by the positive charges inside the atom. Positive charges, that is protons. So the alpha particle is basically a positive charged particle. Therefore when it hits the positive charge particle inside the atom, these particles are deflected back because light charges repel each other. Therefore, the alpha particles which are deflected back are due to the presence of positive charges inside the atom. Right. So he has concluded that the positive charge and most of the mass of an atom, the positive charge and most of the mass of an atom is concentrated in an extremely small region. That is, because the alpha particles are deflected back. That means he has come to a conclusion that the atom consists of positively charged particles. Therefore, he has concluded that the positive charge and most of the mass of an atom is concentrated in an extremely small region. This region is called the nucleus. Therefore, these alpha particles hit the nucleus and the positive charges in the nucleus deflect the alpha particles back. And the alpha particles which pass through the gold foil, most of the alpha particles pass through the gold foil. That means most part of the atom are vacant, right? So the particles pass through the alpha. Most of the particles pass through the alpha foil. Pass through the gold foil. Most of the alpha particles pass through the gold foil, and the particles fall on the screen. Therefore, the positive charge and most of the mass of an atom is concentrated in an extremely small region. This region is called the nucleus of the atom. The negatively charged electrons surround the nucleus of an atom and revolve in circular paths. He said the negatively charged electrons surround the nucleus of the atom and these electrons revolve in the fixed circular paths. The negatively charged electrons are negatively charged. These negatively charged electrons surround the nucleus. The nucleus is at the center. The electrons surround the nucleus and the electrons revolve around the nucleus in fixed circular paths. These paths are called orbits. So the paths in which the electrons revolve around the nucleus are called orbits. These fixed paths are called orbits. The negatively charged electrons and the positively charged particles are held together by a strong electrostatic force of attraction. That means here the nucleus is at the center. All the positive charges are inside the nucleus. Electrons revolve around the nucleus. Therefore, here there is an electrostatic force of attraction between the nucleus and the electrons. They are held together. That is, the nucleus and the electrons are held together by the strong electrostatic force of attraction. The negatively charged negatively charged electrons and the positively charged nucleus is positively charged according to Rutherford. So positively charged nucleus and the negatively charged electrons are held together by the electrostatic force of attraction. These are the postulates of Rutherford atomic model. Then there are some drawbacks in the model. What are the drawbacks in Rutherford atomic model? According to Maxwell, there is one scientist called Maxwell. According to Maxwell said when the charged particles, that is electron is a charged particle, is a negatively charged particle. As the charged particle revolve in orbit, it will lose its radiation, it will emit radiations and it will lose its energy and fall back to the nucleus. That's what Maxwell said. That is, when the negatively charged electrons revolve around the nucleus, it will emit radiation, it will lose its energy and fall into the nucleus. Because of this, the atom will become unstable. This is according to Maxwell. But actually it is not. The atom is stable. The atom is stable. The atom is not unstable. It is stable. Therefore, it is not happening. Therefore, the postulates could not. That is, the Rutherford model could not explain the stability of the atom. Rutherford said the electrons go around the nucleus. So according to Maxwell, when the electrons go around the nucleus, it will emit radiation, lose its energy and fall back to nucleus. According to Maxwell, as the charged particle go around the nucleus, it will lose its energy. But actually it is not happening. That is, the atom is stable. It is not, the atom is always stable. Therefore, the Rutherford atomic model could not explain Maxwell theory. Could not explain the Maxwell theory. So this is the drawback of Rutherford model. And another thing, he did not explain anything about the arrangement of electrons in an atom. Rutherford just said the electrons go around the nucleus, but he had not explained the arrangement of electrons in the